Good day, grade 8 learners. Now let's have our continuation for triangle congruence. Now, take note that in the previous week, we have already discussed about the CPCTC, and that means corresponding parts of congruent triangles are congruent. And there we have established that all the corresponding parts of congruent triangles are really congruent. At the same time, we can also use CPCTC as a reason when we do proof or when we do proving triangle congruence. Alright? Now, another postulate that we can use to prove triangle congruence is the SSS Congruence Postulate, or the side-side-side congruence postulate. Now remember, postulate is defined as accepted statements without proof. So meaning to say, we can use postulates as reasons in our statements when we do proving. Alright? So the side-side-side congruence postulate states that if three sides of a triangle are congruent to the three sides of another triangle, then the two sides are congruent. For example, we have here triangle PMN and triangle SQR. And we see the tick marks. Okay, these tick marks here. So again, we know that the same number of tick marks in our geometric figures expresses or shows congruence. Alright, so here we see that side MP is congruent to side QS. Side PN is congruent to side SR, and side MN is congruent to side QR. So since all of those three sides of each triangles are congruent to each other, then by SSS congruence postulate, triangle MNP is congruent to triangle QRS. Okay, so this congruence postulate is pretty easy. All you need to do is to remember side-side-side. If three sides of a triangle are congruent to the other three sides of another triangle, then the two triangles are congruent. Now let's have an example. So given, we have here given segment or line KL is congruent to segment or side NL. Side KM is congruent to side NM. Now let's prove that triangle KLM, this triangle, is congruent to triangle NLM. Okay. Now, again, when we do proving, first statement will always be the given. So first, we have here first statement is that our first given, which is side KL, is congruent to side NL. And these are sides of our triangle based on our given. So our reason for our statement 1 is given. Next, let's have the other given, which is side KM is congruent to side NM. Now looking at the figure, side KM and side MN are both sides of our two triangles. So they are given. So our reason for our second statement is still given. Okay, because we have two givens here. Next, we notice that in our figure here, okay, side LM, okay, this side is a common side to our two triangles. So meaning to say side LM is common to triangle KLM and triangle NLM. So our next statement will be side LM is congruent to side LM. Again, side LM here is a common side of the two triangles. Okay, so KLM, the third side of triangle KLM is side LM. Same with triangle NLM, the third side is also side LM. So side LM is common to both triangles. For our statement, side LM is congruent to side LM, our reason for that will be okay, the reflexive property. Now remember the table of theorems, definitions, and properties that I asked you to get a copy of in the previous videos. Now, in our proving for this week, we will also be needing that list, so prepare that. Okay, now we have already established that the three sides of both the triangles are congruent. Okay, so therefore, we can now say that triangle KLM is congruent to triangle NLM. And our reason for that will be the SSS Congruence Postulate. Why is it the SSS Congruence Postulate? Because again, look at our first statement. Our first statement, side KL is congruent to side NL. And these are the sides of our triangles. Side KM is congruent to side NM. Okay, so these sides of the triangle. And lastly, we have side LM is congruent to side LM. So all of our statement here are pertaining to the sides of our triangle. No angle, nothing else. So meaning to say, we have already established the congruence of the two triangles using the SSS Congruence Postulate. Okay? Now let's have our second example. So what we have here, given segment PR is congruent to segment RT. So this is PR and RT. At the same time, segment RX bisects segment PT. Okay, so we need to prove that triangle PRX is congruent to triangle TRX. Alright, so as I always say, when we do proving, we always start with the given. So first, okay, we have here side PR is congruent to side RT. And our reason for that is given. Okay? Next, we have also segment RS bisects segment PT. And our reason for that is also given. So the first two statements are both given. Okay, next. Let's understand our second given. Segment RX bisects segment PT. So if segment RX bisects segment PT, we know that X is the midpoint of segment PT. And that will be our next statement. X is the midpoint of PT, of segment PT, and our reason for that is definition of segment bisector. Okay, where did we get that? Because it says here in our given that segment RX bisects segment PT. And since segment RX bisects segment PT, by definition of segment bisector, we know that X here is the midpoint of PT, of segment PT. Now, since X is the midpoint of segment PT, then we can say that from P to point X, that side, and from T to X, this side, they are congruent. Alright? Because we know that a midpoint divides a segment into two equal parts. Okay? So our next statement will be segment PX is congruent to segment TX. And our definition for that will be definition of a midpoint. Now, let's go back to our statements. Okay, let's go back to our statements that established congruency. First, we have the first statement wherein we said that segment PR is congruent to segment RT, and our reason for that is given. So we have already established congruence of one side. Now, in statement 4, we have also established the congruence of side PX and side TX. So we have already two sides that have been established to be congruent. So how many other sides do we need to prove to be congruent so that the two triangles can be proven as congruent also? Of course, we have already two sides here, so we only have one pair of sides left. Now looking at your figure here, we see that side Rx is a common side to both of our triangles. Okay? And since they're common, since segment Rx is a common side, then we say segment Rx is congruent to segment Rx, and just like what we have used as a reason in our previous example, our reason for that will be reflexive property. So again, going back to our statements, we have established congruence of one side, another side, and another side. So we have established congruence of 3 sides. So now we can already say that as a conclusion, triangle PRX is congruent to triangle TRX. And our definition for that our reason for that is the SSS Congruence Postulate. And may I remind you that when you do proving, you should always end with a statement of the figures that you want to prove. Okay? Alright, now that we are done, let's proceed to our next example. So we have here given the figure, solve for the value of x. This time we are not proving, but instead we are solving for the value of x to find the measure of segment RP and segment RT. So we are looking for the measure of this side and this side. Okay, now we know that if 2 sides of a triangle have the same number of tick marks, then these 2 sides are congruent. Alright, so now we can start with our solution. So first, we start with segment RP is congruent to segment RT. And that means the measure of segment RP is equal to the measure of segment RT. RP is equal to -1 plus 14x equals 12x plus 17. Solve for x, isolate all the terms having x on the other side and all the terms not having a variable on the other side. So we have here 14x transpose 12x to the other side. Positive 12x becomes negative 12x. So we have minus 12x. That's equal to 17. Transpose -1, it becomes positive 1. So we have here 14x minus 12x, that is 2x, equals 17 plus 1, that's 18. So x is equal to 18 over 2, and x is equal to 9. That is your value of x. Now, remember that we are not looking for the x value only. We are asked to solve for the measures of segment RP and segment RT. So solving for the measures of segment RT and RP, of course, we need to just substitute our value of x. So solving for the measure of RP, we have so RP here is -1 plus 14x. So we have -1 plus 14x. That is -1 plus 14 times the value of x, which is 9. Okay, so we have -1 plus 14 times x. 14 times 9 rather. We have 126. -1 plus 126, that's 125. So the measure of segment RP is equal to 125, okay, let's say units. Now let's have segment RT. The measure of segment RT is equal to, okay, 12x plus 17. Substitute, you have 12 times 9 plus 17. So you have 108 plus 17, and that will give you 125. So the measure of segment RT is equal to 125 units. And highlighting our measurements, we see that the two sides are indeed, the measure of the two sides are indeed equal, so the two sides are congruent. Alright, so for this example, x is equal to 9, and the measure of segment RP and segment RT are 125 units. Okay, so I hope you learned something, and there are still 2 remaining postulates for triangle congruence, so check on that. See you in our next video.